slope and graphing of linear equations. By the end of this video, you should be able to identify the y-intercept in a graph, identify the slope of a line, and write the equation of a line in slope-intercept form. And you should also be able to calculate slope. Alright, so what is slope? I just said that word a whole bunch of times. So slope, and when I said that, several of you probably thought this: rise over run. And that's exactly what we're talking about. We're talking about the change in your rise and run. So for lines, there's a constant change. That means the slope will be the same no matter what 2 points you pick. So there is a constant rate of change between points on a line. So no matter what 2 points, so if I had a line and I picked these 2 points and I found the slope, if I then went and picked these 2 points, they would have the exact same slope. It does not change between any of the points. So the slope is a ratio. And when I say the word ratio here, I'm meaning dividing. So this is rise divided by run. So it's a ratio of the rise to the run. When we use the slope formula, we always use the same variable. M stands for slope. Alright, there's different kinds of slope that I want you to remember. I'm going to draw my coordinate plane here. That's my x-axis and my y-axis. And now when you look at graphs on a coordinate plane, you always read from left to right. So if I had a line that went from left to right, and it went up as it went left to right, that is called a positive slope. Okay? Make my coordinate plane. If I'm reading my graph from left to right and my line is decreasing as it goes left to right, that's going to be a negative slope. Two more that hopefully you're going to remember. There's my x and y axes. If I have a line that goes perfectly straight across, a nice horizontal line, this is called a zero slope. And the reason it's called a zero slope is this line, it's never going up or down. It's not tilted like these other lines were. So it has zero rise, but it runs forever and ever left to right. Zero divided by anything is zero, so that's why it's called a zero slope. And for our last line, if you have a perfectly vertical line, like this, this is called undefined. Now the reason this is called undefined is you have all sorts of rise. It's going up, it's going down, so we have a rise, but it never goes left or right. So there's zero run, and you are not allowed to divide by zero. That's an undefined action. Okay, so hopefully that will help you remember a little bit about zero and undefined. So what I'd like you to do is pause the video, name these as positive, negative, zero, or undefined, and then come back and check your answers. Alright, let's see how you did. Alright, so left to right, this line's decreasing, negative. This is a perfectly horizontal line. Those are zero slope. This line is increasing as it goes from left to right. Positive, decreasing left to right, negative. Hopefully you did very well with that. Now we're going to actually talk about how to calculate slope. So this is something you have done before. And so we're going to use our slope variable to find the slope. You need to take the y values and find the difference in the y values, and then put that over or divide by the difference in the x values. So here's kind of what we're going to talk about. So we have a point, x and y. Then we have another point, x and y. So to help me figure out which point is which, I'm going to say this is x1, y1. They're in the first point. This one will be x2, y2. They're in the second point. So now the order in which you subtract these doesn't matter. The official formula that many of you have seen that says take y2 minus y1 and divide by x2 minus x1. That's fine. I like to stack my points like this. It makes it a little bit easier to see. y2 minus y1 divided by x2 minus x1. But you can also set this up y1 minus y2, provided you also then go back up and start again with x1 minus x2. You have to subtract in the same order because order makes it different with subtraction. And we're real good at remembering that slope is rise over run. And that should help you remember that the y's are on top because rise means up and down and run means the left to right. So y values are up and down and x values are left and right. All right, let's find slope using some different representations, shall we? So first one we have is a graph. The way I like to address these is to go to the y-intercept, which is where the graph crosses the y-axis, and then count to the very next place where the graph lines cross each other. These lines are called lattices, so I want to know where the lattice run into each other in an exact point. And then I'm going to rise first, and I had to go up 2, and then I had to go right 1. So I had a rise of 2 and a run of 1, and we're just going to simplify that as just 2. So my slope on this line is 2. We can even check it to get to the next exact cross point is right here, and I go up 2 and right 1. So that's that constant rate of change. It's going to be the same each time. So for our points, we're going to use our formula. I'm going to go ahead and stack these like I was talking about before. It just makes it can make it easier for you to see. So I'm going to say my slope equals y minus y, so I'm going to say 1 minus 5. Because I started with the 1, I got to use the x value first from the same point. So I'll say 2 minus, and then it's negative 3. So 1 minus 5 is negative 4. And then 2 minus negative 3, that minus minus becomes a really big positive over 5. So my slope is negative 4 over 5. So that means I would go down 4 and right 5. Okay, table of values. You could pick 2 points out of the table of values and do what we just did right here, but I'm going to show you another way to check out our slope. So let's look at our y's. We're going to add 4 each time. This is the same as what we would have done in the equation, and we notice it's the same number. So that's our rise, because that's the y value. So it's going to be a positive 4 on top. And now let's look at the x values. How are they changing each time? There's a plus 1, they plus 1 again, they plus 1 again. So it's always plus 1, so it's going to be 4 over 1, which will simplify down to just 4. So that means go up 4 and right 1. All right, one last representation for you is a word problem. We just did a bunch of these. So you're going to the fair. The cost to attend the fair is $7 entrance fee plus 50 cents a ride. So no matter what, you're spending $7 to walk in the door plus 50 cents per ride. Now the slope is how things are changing every time something happens. So it's depending on the number of rides in this case. So the number that's next to the variable, that is always your slope in a linear equation. The constant, this number without a variable, that's your y-intercept. This number next to the variable, that's your slope. So in this case, your slope equals 0.5. All right, let's take a look at the back. So this is what I was just alluding to on the front. Here we have a linear equation, and most of you are familiar with this, y equals mx plus b. And your m is next to the variable x. And we just were talking about how m represents slope, so the m is slope. And the b is your y-intercept, where the graph crosses or touches the y-axis. Okay, so what we're going to do is we're going to write some linear equations in slope-intercept form, and all you have to do is identify which is the slope and which is the y-intercept and plug them in for their spot. So here we have slope equals 2, so m equals 2. The y-intercept equals -1, so that means my b value is -1. And I'm literally going to take the equation and I'm going to substitute in for m and for b. So in this case, I'm going to say y equals, instead of the letter m, I know m to be 2, mx, and my b is a -1. Now we've written the equation. It's that simple. What I'd like you to do is pause the video and try these next two and see how you did. All right, let's see. So we took our slope and plugged it in for slope, our y-intercept for y-intercept, y equals 3 over 5x plus 4. And our last one, y equals -1x. If you don't have the 1 written there, that's fine, but you do have to have the negative sign. So you could have just had -x plus 7. These say the same thing. All right, so this is slope-intercept form because in the equation you can see the slope and you can see the y-intercept. That's why they named it that. And there's another way that lines are often written. It's called standard form. That's when x and y are on the same side of the equals. When we're given the x and y on the same side of the equals like this, we're going to want to treat it like a literal equation that we just did, where we always solve for y. So you're always going to solve these for y, and then it will be in slope-intercept form. So let's take a look. Here's my y value. I notice that there's a plus 2x over here on the same side as y, so I want to get y alone. So I'm going to use my inverse operations and subtract 2x from both sides. It's going to cancel on the left, and I'm left with y equals. Now when we write these, remember our slope-intercept form is mx plus b. So I'm going to write the slope and x term first, mx plus b. Okay, let's try it again. You're trying to get y alone, so that means you want to move the x term first, so we'll use your inverse operations and subtract 4x from both sides of the equation. They cancel on the left, and I'm left with 5y equals -4x minus 30. Now, if there's still something in front of y, you got to go ahead and divide each thing by whatever that is. So in this case, it's a 5. And that leaves me with y all by itself. If this is a fraction that doesn't reduce down to a lower fraction, a smaller fraction, just leave it as it is. So -4 over 5x, and then -30 divided by 5 is -6. So this says you're going to go down 4 and write 5. Okay? Pause the video and try this last one on your own. All right, so how'd you do? You moved your 4x over, that left a -y. You can't forget about the sign that's in front of it. So that means there's really a -1 right in front of the y. So you have to divide each thing by -1. And because you're dividing by 1, none of the numbers or variables, nothing changed except their signs. They went from all negative to all positive. All right, now we're going to graph these linear equations in slope-intercept form. It's the easiest way to graph. So if it's already in slope-intercept form, you're good. If it's not, like it's in the standard form, solve for y, so you're in slope-intercept form, then you're going to plot the y-intercept. Remember, that's your constant on the end. You're going to plot that first. And then from there, you're going to count your slope out and then connect everything with a line. So let's take a look. So we have this equation, y equals 2x plus 1. So my slope is 2 over 1. And my y-intercept is 1. So So you want to go to where y equals 1 and put, so where y equals 1 is right there. So that's your y-intercept, this. Now I have a slope that's really 2 over 1. Any whole number, any number can be put over 1. It doesn't change its value. So that means you're going to go up 2, because that's a positive 2, and that's a positive 1, and positive x values are to the right. So you're going to go up 2, right 1, and drop another point. From there, up 2, right 1, drop another point. Up 2, right 1, drop another point. Now, do you remember, what if I ran out of room and I wanted more points and I wanted to come back over this way some to help me draw the line better maybe? So this says go up and right. To go opposite, I'm going to go down and left. So I could go down 2, left 1. Do you see how it's still following the same pattern? Down 2, left 1. Once I get all of those, I take my handy dandy Scooby ruler and I line it up as best I can. I draw a big long line across the whole graph and I put arrows on the end of it. And that's how we're going to graph. Okay, so let's take this second one. So here I have a slope of negative 2/3. When there's a negative sign in front, I usually write it on the top. It's just easier to put it with the top guy. Negative 2/3, and my y-intercept is negative 3. So where y is negative 3, 1, 2, 3, drop your first point. Now, negative 2 over 3 for my slope means go down 2, and that 3 is positive. So you're going to go right 3. Okay, so from here, down 2 and right, 1, 2, 3, drop another point. Down 2, right, 1, 2, 3, drop another point. If you want to have some points going the opposite, this is down and right, so you're going to go up and left. Up 2, left 1, 2, 3, up 2, left 1, 2, 3. So you can see how the trend was followed. Then I'm going to take my handy dandy ruler. I'm going to connect my line all the way across the graph, and I'm going to put arrows on the ends of it. Alright, what I'd like you to do is pause the video and try this last one all on your own. Alright, so we started at negative 5 because our y-intercept was negative 5. Our slope is negative 1 over positive 1. So that means it goes down 1, right 1. So from our y-intercept, down 1, right 1, down 1, right 1, all the way. And then I did some up and lefts too to continue my pattern the other way. And drew a line all the way across my graph and put arrows on it. Okay, our last 3. So I have a special case here. It says you agreed to watch your neighbor's little girl for the day and you'll get paid $8 for the whole day, not per hour. It does not say per hour there. So, but notice it says x equals 8, not y equals 8. Right, well, where is x 8? 1, 2, 3, 4, 5, 6, 7, 8. X is 8 right there. But is that the only place x is 8? If I went to this point right here, that is 8, 2, but the x is still 8. What about if I went here? That x is still 8. What if I go down here? That x is still 8. In fact, every point along this this vertical line has an x value of 8. So that's our line. This is an undefined line. Anytime you have x equals a number, that's an undefined line, if that's your equation that you have to graph. Our middle one, notice we're not in standard form. We're in standard form, we're not in slope-intercept form. So what you want to do is you want to solve for y to get it into slope-intercept form. So we're going to subtract the 2x from both sides. And you get y equals negative 2x plus 6. So your slope is negative 2 over 1. That means go down 2, right 1, and your y-intercept is 6. So find where y is 6. 1, 2, 3, 4, 5, 6. Drop a point. From that point, you're going to go down 2 and right 1. Down 2, right 1. And keep doing that until you're happy with the amount of points you've got to make a line. If you wanted more lines the other direction, instead of down and right, you go up and left. I'm going to take my ruler, connect it, and put some arrows on it because we don't have any indication that the line's stopping in any way. Now your last one. This is very similar to this guy over here. This says x equals 8, but this one says y equals 7. So where is y 7? 1, 2, 3, 4, 5, 6, right there. But is that the only place y is 7? Y is 7 in here, and y is 7 here, and y is 7 here. So in this case, I'm going to turn this to make it a little bit easier to draw. I end up with this horizontal line that goes through the y-axis at number 7. Okay? This line went through the x-axis at number 8. All right, hopefully that was helpful. See you in class.